Yeah. Okay, so 2.1. So what we have is we have questions, and this is talking about our average rate of change. And for number 3, it was asking for that cotangent one. I'm going to go ahead and go through the cotangent one with you because there's nothing that's extremely similar. So what they give us is they give us f of x. I know they call it h of x, but let's just, whatever. F of x is equal to the cotangent of x. I will do A, and you guys will have to do B, okay? So A asks us this pi over 4 all the way to 3 pi over 4. So what we know for our solution here is that when I ask for the average rate of change, and what I'm going to do is I'm going to simplify this always to change in y over change in x, so I don't have to write average rate of change every time. We know that it's going to be f of x2 minus f of x1 all divided by x2 minus x1. You guys agree? Now what are these values right here? What's this pi over 4 and this 3 pi over 4 represent? Yeah, it's x1 and x2. This is x1 and this is x2, isn't it? So when you plug those numbers in, you know that this is going to be, well, f of x2 is going to be f of pi over 4 minus f of x1, which is f of 3 pi. I got that wrong. x2 comes first, so 3 pi over 4. This will be pi over 4 all over x2, which is 3 pi over 4, minus x1, which is going to be pi over 4. Is that clear? Okay. Now, after I plugged in the x2 and x1, what else do I have to use? What's next? Yeah, now you have to use the f function, right? So f function means that these values are going to go right into this t position, right? And this value is going to go right in that t position, isn't it? So when I do f of x2, this is going to be f of x2. This piece right here is the cotangent of 3 pi over 4, right? That 3 pi over 4 is going in that t location. And also the pi over 4 is going to go in that t location, so minus the cotangent of pi over 4. All divided by 3 pi over 4 divided by, minus pi over 4. Is that clear? If I'm ever out of frame, or if I'm ever out of focus, you guys let me know, okay? So the idea is, how do we find like the cotangent or the tangent, the sine or the cosine? So in your pre-calc class, just like this class, I'm going to let you guys have a unit circle so you guys can do this with speed. So a unit circle looks like this. And remember what the unit circle tells us. It tells you for values of what? Sine and cosine. So if I ask you, what is the sine of, say, pi over 6? Well, what we do is we go to the angle pi over 6, which is right here, right? What one represents the sine? Is it the x-coordinate or the y-coordinate? Y. That's right, because remember, these things are of the form x comma y. You guys agree? Mm-hmm. X comes before y alphabetically. And notice how c comes before s alphabetically? So that's how I memorize it. So the first one, this represents the cosine. This represents the cosine of that angle. This represents the sine of that angle. So if I want the sine of pi over 6, what's the y-coordinate, right? So this is 1/2. Now if I want the cosine of pi over 6, well, that would be the x-coordinate. That would be this one, right? It's going to be root 3 over 2. Now, now that I know the unit circle and how to use it again, how's the cotangent built? Well, yeah, the cotangent of t is going to be the cosine of t all over the sine of t. Is that clear? That's how we find the cotangent? So that means that for this piece right here, this 3 pi over 4, the cotangent of 3 pi over 4 is going to be the cosine of 3 over pi over 4 divided by, well, the sine of 3 pi over 4. Is that clear? That's what cotangent is? It's cosine of the angle over the sine of the angle. Minus the same thing here. Cotangent of pi over 4 is going to be the cosine of pi over 4 divided by the sine of pi over 4. So that represents the cotangent of pi over 4. All divided by that same 3 pi over 4 minus pi over 4. You guys mind if I just write that as 2 pi over 4? Okay, and then I'll simplify it to pi over 2 in a second, okay? So when you subtract those, you subtract your numerators, keep the denominator. Now we just refer to the unit circle. So looking for 3 pi over 4. Well, 3 pi over 4 is right here. You guys agree? So what's the cosine of 3 pi over 4? X or y coordinate? X. So that's the cosine, isn't it? Which means this is the what? The sine. So I know that the cosine is going to be your negative root 2 over 2 divided by the sine, which is positive root 2 over 2. That's this piece right here again, right? Okay. Minus the cosine of pi over 4. Now go back to pi over 4. Pi over 4 is over here. Cosine is the x-coordinate. Sine is the y-coordinate. and they're both root 2 over 2 in this case. So the x coordinate is root 2 over 2, the y coordinate is root 2 over 2. All divided by, I'm going to write this as pi over 2 now. I'm going to simplify it a little
Wait,
more.
so that's the square, so that's negative square root of 2 over 2 over,
Well, let's not go so, let's not think about it too hard. Like, what if I say, what's 3 over 3?
read that. You can barely read.
I can zoom in. It's not a big deal. Is it fuzzy or is it just small?
It's just too small.
Okay.
And the bottom one would be pi over 2, not 1 over 2.
Did I write? I did that last class too. Dang it. I can't fix it. Oh well. So, what would 5 over 5 be? 1. So what's root 2 over 2 divided by root 2 over 2? 1, because it's the same numerator, the same denominator. What would this one be? Okay, so what we have is we have negative 1 minus positive 1 all over pi over 2.
So it's 0 over pi over 2.
Well, not quite. What's negative 1 minus another negative 1?
Oh, negative.
So this is negative 2 divided by pi over 2. Now remember, this is our fraction bar. You guys agree? That's the fraction bar,
The 4.
which is this same thing. We'll get there. Which is this fraction bar right here. You guys agree that's the same fraction bar? So when I say I have to divide by the reciprocal, I need to know what the denominator is. And since there's 2 fraction bars, we need to know what the denominator is, right? That's the denominator. So I'm going to have to flip that thing, right? So this is going to be minus 2 times, dang it, this should be a 2 again. Whatever. So 2 over, but not whatever, it's wrong. So this is going to be what when we're done? Yeah, so when I multiply this negative 2, does it go top or bottom or both? Yeah, because this is minus 2 over 1, right? So this would be equal to minus 4 over pi. Last little bit of paper. Yes, made it. So that's our solution. All right, number 5. All right, you guys are picking ones that, I'm going to do something similar. I'm just going to have to change some numbers. What could I do? I got nothing. I'm gonna have to just do the problem then. Oh well. So, little disclaimer. If I do your homework, you gotta go back and still do it, okay? Now, a really big thing I want to tell you guys is if you just copy down my work, you're not learning anything. So what I recommend you guys do is go back to the homework and see if you can do it without looking at my work. If you can do it without looking at my work, you guys are ready. Make sure when you guys are studying for tests, shut your book, shut your notes, write down a problem, and then see if you can do it. If you have to open your book or open your notes, that's not good for a test, right? So that means open your notes and figure out the problem, close the notes, rewrite the problem, see if you guys can do it. So as soon as you can do it without opening your book or opening your notes, you are test ready. Okay? So just be sure to study. When you're trying to study for a test, put yourself in testing situations. Is that clear? Don't keep your notes and book wide open. There's going to be a lot of memorization in this class, yeah. That's just part of calculus. But it'll come little by little, okay? So I will give you a unit circle because that's enough, all right? But when it comes to cotangent, you have to know cosine over sine. Tangent, sine over cosine. When you start learning derivatives, you're going to have to memorize those things as well. There's the little derivative tricks. But every class has done it since the beginning of the time. You guys will be fine, okay? All right, so number 5. R of theta is equal to root 4 theta plus 1, where 0 is in between 0 and 2. Now you guys are welcome to write this as f of x and just change the thetas into x's if it bothers you. But what we know is our average rate of change, our change in technically r over a change in theta. Is that clear? That r is essentially our y value, and theta is essentially our x value. So this still looks like change in y over change in x. So dependent over independent is kind of the idea. And the independent variable, the thing that's on the bottom is what you're plugging in. So this is going to be equal to r of theta 2 minus r of theta 1, all divided by theta 2 minus theta 1. Is that clear what I'm writing there?
Imagine it's an x.
Just pretend that's an f and pretend that's an x, right? If that was the case, then all the things are in the same position, aren't they? You know, a lot of times on my test, I just redefine that to be y of x is equal to this thing, and then I'd just be done, or call it f of x instead. Because you're welcome to redefine anything you want, right? Then it'll be exactly the same thing. It's just a direct change of variables. Okay, so what I know is that this thing right here is your x1, x2. But in this case, what's x called? So this is theta 1, this is theta 2. Is that clear? So plugging things in. This is going to be r of 2 minus r of 0 all over 2 minus 0. And then plugging the values in. So 2 is going to go into this function, isn't it? So this is going to be the square root of 4 times 2 plus 1 minus the square root of 4 times 0 plus 1 all over 2 minus 0. And then we simplify. You guys agree that these things are pretty, like, what's under the radical? What's the radicand here? 4 times 2 plus 1? 9. So this is square root of 9 minus the square root of all over 2, right? Square root of 9 is minus all over 2 over 2, which is 1. So that's your average rate of change. So let's talk about what average rate of change really means. So what we have here is we have some, I'm going to draw a picture. I'm not sure what it exactly looks like. I know it's a radical, so it's going to have some kind of look that looks like this. Let's just pretend it looks like that. It's not, but it's a radical, so it has something like that. So what we're doing is we're doing an average rate of change from 0 to 2, right? So what I'm looking at is I'm looking at the slope of the secant line. So in that case, m is equal to 1 for that particular line. That's what we're representing. So what does it mean in real life? So say I'm driving from my house to here, and I'm going about 20 miles per hour, 25 miles per hour in my neighborhood. I get on the highway, I'm going about 50 miles per hour. I get on the expressway, I'm going 80 miles per hour. I get back on these roads, I'm going back down to 35, finally the Port Huron at about 25. But my average rate of speed over that entire distance is probably about 45 to 50 miles per hour. Does that make sense? So when a cop pulls me over on the expressway and says, hey, you were going 80, I'm like, no, officer, my average rate of speed is 50 miles per hour. Right? No. So what the officer is actually looking at is not your average rate of speed. He doesn't care how fast I was going over a time period. He cares how fast I was going right now, right? So that's the difference between average rate of speed as opposed to instantaneous rate of speed. So when we're doing instantaneous rate of speed, that's what your speedometer tells you. It tells you the slope of the tangent line. So this is the slope of the secant line. This is the average rate of change over this interval, right? From 0 to 2. Number 7. Okay, I'm just going to make something up.
I have a question.
Yes. I'm doing
So,
8.
if you want to know how fast you were going in the car for the whole trip, like the average speed, what you could take the fastest speed, you could do it by taking the fastest speed you were going and the slowest speed you were going?
You cannot. You cannot, because that would assume that my speed is constantly linear. If my speed was constantly linear, then yes, you could just take your max and your min and take the average of them. So that's a good question. So we got to go there now. That's just too cool. So think about it this way. So if I want my rate of speed, say my rate of speed starts at 0 and goes all the way up to 50 miles per hour. And that's very linear. You guys agree? So my average rate of speed is going to be right there. It's going to be right in the middle, right? Which happens to be 25 miles per hour. Which is nice because the average rate of speed and your slope ought to be the same thing. You guys agree? Okay, now, unfortunately, this is me. Vroom, right? You guys agree?
Yeah.
So my average, sound effects help. My average rate of speed is not going to be in the middle anymore, is it? It's going to be higher because this is a little steeper, isn't it? So it's going to be more up here as opposed to down here. So if it's linear, yeah, you could just average max and min, but it's not linear. So we have to get around that, which is going to be taking the slopes of tangent lines. So it's going to be able to take something like this, which is what we're used to, and then be able to do something like this, which is the way physics works, right?
But you couldn't take your maximum speed, your minimum speed, and put it into a tangent line function thing?
It would be an average that would be not exactly the same. It would be an estimation, but it's not correct. Okay, so let's do number 8 instead of number 7. You guys can do number 7 yourself. So number 8, it says it gives us a function and it gives us a point, and what it's asking us for is. So I'm going to start over because I want to use all the paper. So number 8 says our function f of x is equal to 7 minus x squared, and it's going to be over a particular point, so from 2 to 3. So just to look at the instructions for both of these, so we go back to see. Now for the instructions for 1 through 6, it says find the average rate of change, which is what we just did, right? But for 7 through 18, they said use the method in example 3. You guys can go back to example 3. That's the one with the h's. In order to find the slope of the curve at that given point. After you know the slope of the curve, we can find the tangent line as well. So we're going to go through that with number 7. So what we're going to do is, instead of finding the slope of the secant line, which we have right here, you guys agree this is the slope of the secant line? Was there a way maybe I could say, what about the slope at 0? Was there a way to maybe find the slope of that tangent line? And there is. So that's what we're going to eventually do, okay? So, but we're going to find the slope of the tangent line of this quadratic as opposed to that radical. So remember what this point gives you. This is no longer an interval. This is an x comma y. That's why they put a p here, okay? Just to make sure you guys know that this is a point. Does that make sense? So really this is going to be x1 comma y1. Is that clear? That's what that's represented by? Okay. So if I want to find the slope, the instantaneous rate of change, which is equal to the slope of the tangent line, what we're going to do is we're going to use change in y over the change in x, which is going to be equal to your f of x1 plus h minus f of x1 all over h. You guys remember that formula? Now h represents the length of your interval, right? So if we go back to our previous two problems and kind of just discuss those. Like in the very first problem, you guys agree h was this. This is the distance between your interval. So in this case, h is going to be pi over 2. In the next one, we had h is going to be the distance between these 2 points, so h is equal to 2. But we can see since h is equal to 2, that gives us a secant line, right? If I want a tangent line, what do I want h to be? 0. I want h to be 0. So what we're going to do is we're going to simplify this. First, we're going to plug it in. We're going to simplify, and then we're going to plug in h equals 0. So first, simplify. Second, plug in h equals 0. And that's going to give us the slope of our tangent line, okay? Okay, so what's x1? So let's start out with this. So the change in y over the change in x is going to be equal to f of x1 plus h minus f of x1 all over h. What's x1? 2. So f of 2 plus h minus f of 2 all over h. So the same thing we did before, right? We plugged in the values. Now what do we do with these two values? Plug them into what? Into this. Plug it into this function right here. So this is going to be equal to, remember what this means is 2 plus h has to go in this x position. You guys agree? So it's going to have to go right here. It's going to have to go in this x position. So that 2 plus h is going to go in that position. So this is going to be equal to 7 minus, well, 2 plus h squared. You guys agree that's that function evaluated at that point? Minus, don't forget what? Starts with the p.
Point.
The other one, pa, parentheses. Yeah, don't forget parentheses, because remember, we're subtracting, right? So I need to subtract the entirety of what I have here, and since this is going to be a binomial, don't forget you're going to have to subtract that 7 and subtract whatever that thing is as well, right? So we're going to have to also put 2 in that function. So when I put 2 into here, this is going to be 7 minus, well, 2 squared. And again, this piece right here is this, and this piece right here is this, right? All over h. So we did it. We did this part, right? Now we have to simplify. You guys agree? Okay, simplifying. So remember when we simplify, it's the same thing we did in pre-calc. Please excuse my dear Aunt Sally, right? Now the reason why I put M and D and A and X next to each other like that is because whatever comes first, right? From left to right. So when you guys see that Facebook stuff where they say, hey, can you get the right answer? Well, it's extremely bad mathematical grammar. No mathematician would write it like that. They're writing an equation to be ambiguous on purpose, and it makes me angry. Sorry. So, all right. So, what do we do first? Well, we do parentheses first, but there's nothing to do in the parentheses. You guys agree? So we have to do exponents next. So what's 2 plus h squared?
4h
2 plus
squared,
h times
4h
2 plus
squared.
h.
Yeah, remember that we have to multiply this, right? Do not distribute those powers. I will lose my mind. Okay, so this is 2 plus h times
2 plus h.
2 plus h. Okay, I make a big stink out of it because it's a very common error, okay? Lose my mind is a little harsh, but... So there, I did the powers, right? Now that you've done the powers, now you have to do what? Multiply. So we're going to multiply these things. So don't forget this parenthesis here, because you still got subtraction, right? Every time you see subtraction, be careful. So 7 minus, well, 2 times 2 is 4. Outside is?
2h.
Inside is?
2h.
So that's going to be 4h, right? And then last is?
h squared.
H squared. Minus
3.
3. All over h. Okay, now we're almost done. So now we're going to distribute. Remember, we're not done multiplying, because that's technically multiplying is distributing, right? Okay, so this is going to be 7. This is going to be minus 4, minus 4h, minus h squared, minus 3, all over h. And what's really interesting here, if I'm ever out of frame up, you know, I bet you anything that doesn't have an h on top is going away. What's 7 minus 4?
3.
You guys agree? Okay. So what I'm left with is minus 4h minus h squared all over h. Remember, I'm trying to plug in h equals 0. You guys agree? I can't plug in h equals 0 here, because what's going to happen to the bottom? It's going to be 0, and the bottom's not allowed to be 0, is it? It's going to be undefined. But what do you think I'm going to be able to do with that h?
Take h out of everything.
I'm taking h out of the top. So taking h out of the top, I'm left with minus 4 minus h all over h. Now what happens to that h? Cancels. So this is going to be equal to minus 4 minus h. Can I plug in h equals 0 now? Yes, now that denominator has been taken care of, you can. So now plug in h equals 0. This is now the instantaneous rate of change. What's kind of interesting here is if I had like maybe an interval that went from 2 to 5, let's do better, 2 to 6. You guys agree that distance would be 4? You could just plug in h equals 4 into this equation. That would give you the average rate of change. If you went from 2 to 7, h would be 5. Just plug in 5. That'll give you the average rate of change for that. But I want that interval to shrink all the way down to 0, don't I? So since I can, notice how 0 is now defined. So this is going to be minus 4 minus 0, so this is minus 4. So this right here is our average, is our instantaneous rate of change. Next, they ask us to find the, so this is A, instantaneous rate of change. B, they ask us to find the equation of a tangent line.
We asked the slope of the curve.
That's what it is.
Oh, that's what the instantaneous.
That's
change is.
right, tangent line.
Okay.
So I got a question here.
Why did it have to be?
I'll get there.
So confusing.
We'll get there. Let me finish this one. So equation of a tangent line. When I say equation of a tangent line, what's the most important word in that? Line. How do you find the equation of a line? You need a slope and a... Boy, I need more coffee. So, and a point. So how do you find the slope? We just did, didn't we? The slope of that curve, the slope of that equation of that tangent line is the instantaneous rate of change, right? So I know that was negative 3, negative 4, negative 4. And how about the point?
They give it to you.
They give it to you, and that is 2, 3. So now that I have those things, remember how you find the equation of a line is the equation of the line, right? Y minus y1 is equal to m times x minus x1. Your point slope formula, because I have a point and a slope. I like to send the y1 over, because then it looks more like a transformation. So, you know, shift right of x1, stretch of m, up y1. This is that's technically what that is. That is a transformation of a line. Okay, so what's m? Negative 4. What's x1? 2. What's y1? 3. Good. So this is x minus 2 plus 3. So I'm going to have minus 4x plus 8 plus 3. So minus 4x plus 11. Okay. So let's prove it to ourselves now. Now this is where everything comes together, and you hope you didn't make something stupid, okay? So I'm going to put it on the calculator real fast. Minus 4x plus 11. We're going to have to go up a little bit. So this is the equation of the tangent line, right? At the point 2 comma 3. Okay, we should be good here. Let's give it a shot. So my original function was y equals, let's clear this out, 7 minus x squared, right? Okay? And then our tangent line is minus 4x plus 11. So what I'm hoping for is I'm hoping to graph the first one and see that radical. There you go. And then a tangent line. Come on. There you go, buddy. Oh, you can't see it. It was less dramatic, now they can't see it. So can you guys see that this is that quadratic? This is that 7 minus 4x, right? Up 7, flipped over the x-axis. And this is that tangent line, and what point does it cross? What point is that? 2 comma 3. Does that make sense? So this line is that minus 4x plus 11, and this is that original quadratic.
How did you put that in there?
I just went to y equals. I popped the 2 lines in. I popped the original function in, then I popped the tangent line in, and I just said, go. You don't have, you don't,
Are you gonna allow us to check like that in the past?
sure, but it's not gonna provide you any more points, but you're welcome to check to see if you're correct.
Well, if you're wrong, then you can try to fix it.
That's absolutely right. So you do have technology at your fingertips, right? So you should know if you're wrong, right? Assuming that that point lives in the window that we're expecting, right? So you might have to change windows and stuff, but remember, answers don't give you points, it's the work. Next.
If you have the right word. If you have the right answer and the wrong word, yep.
Can't believe you guys didn't ask 15.
What?
Can't believe you didn't ask 15.
I don't think anything got there.
All right. I will do a cubic if you want me to. We're basically out of time, guys.
What?
Yeah, we're out of time. So I will do a cubic after class if you guys want to see it, okay?
Are we doing the next note?
Yep. Tell you what, I have, I'm going to stop this.